Hello everyone, welcome to CSCI453-553 Digital Image Processing class. Histogram describes the distribution of pixel intensity. As you can see, the image on the left is a grayscale image of size 300 by 332. And the image on the right is the 256-bin histogram of the image on the left. You should observe that in the histogram and in the statistic under the graph, the highest peak occurs at the intensity level 254, which is the white dog fur. In addition, the bars between the intensity level 0 and 60 represent the eyes, nose, and some dark regions. The histogram shows that the pixel intensity level range between 80 and 255 has the most pixel counts, and the majority counts occurs between 80 and 210. This indicates that the image is middle gray to white. In this example, we demonstrate various brightness levels of the same image. As you can see, the first row shows 3 grade level images. The center image is the original image. As you can see, the image on the left has lower brightness, and the image on the right has higher brightness. The corresponding histogram is shown below. As you can observe from the 3 histograms, the distribution of the peaks and valleys in the histogram is highly similar. The only difference is that in the image with lower brightness, all bars are shifted to the left, while in the image with higher brightness, all bars are shifted to the right. We will show you how to generate this example in MATLAB. Here is the MATLAB code to produce the histogram comparison example aforementioned. As you can see, we read a grade level image as a matrix named IM capital G. To compare the images with different brightness and their corresponding histogram, we create a figure window. In order to achieve the side-by-side comparison, we split the figure window into 6 subplots, which is arranged as 2 rows and 3 columns. As you can observe, the subplot function has 3 parameters, where the first 2 parameters indicate how to split the figure window. In this case, we want to split the figure windows into 2 rows by 3 columns. The third parameter indicates the subplot ID. So what is subplot ID? Once we split the figure window into subplots, we number each subplot with a number. The order is from top to bottom and from the left to the right. Therefore, the left subplot in the first row is numbered as 1. The center subplot in the first row is numbered as 2. The right subplot in the first row is numbered as 3. We continuously number the subplots in the second row, where the left subplot in the second row is numbered as 4. The center subplot in the second row is numbered as 5. And the right subplot in the second row is numbered as 6. As you can see in the sample code, we want to display the image with low brightness in first row on the left. Therefore, we specify subplot ID 1 in the third parameter to show G minus 50, where G is the original image. The minus 50 operation will decrease the pixel intensity level by 50 for all pixels. In case any pixel intensity becomes negative values, the pixel intensity will be set to 0 because the minimum value of uint8 data type is 0. Similarly, we show the image with high brightness in the first row on the right. Thus, we specify the subplot ID 3 in the third parameter to show G plus 50. The plus 50 operation will increase the pixel intensity level by 50 for all pixels. In case any pixel intensity exceeds 255, the pixel intensity will be set to 255 because the maximum value of uint8 data type is 255. It is worth noticing that histogram can be used to describe the pixel intensity distribution, and thus is usually used to represent the character of an image as a visual features. However, two different images may have the same histogram. For example, the two images on the screen have identical histogram due to the fact that the number of gray pixels and the number of white pixels in both images are the same. The only difference is that the location of the gray pixels and the white pixels are quite different. Basically, the histogram will be used to describe the distribution of pixel intensity level. However, it's not fully describe the location of the pixel intensity level. So far, you have learned what is the brightness of an image and how histogram describes different brightness level. Now, we will talk about another important property of an image, that is, contrast. Simply speaking, contrast is the difference for your eyes to differentiate the foreground from the background. To help you understand the concept of image contrast, we will use an example. As you can see on the screen, there are 4 statements. Can you see this message displayed on a white background? The 2 statements on the top use darker font color, while the other 2 statements at the bottom use brighter font color. You can easily see the two statements on the top because the contrast between the dark fonts and the white background is high. Contrarily, the two statements at the bottom is difficult to read due to the low contrast between the bright font and the white background. Guess what will happen if the same statement are displayed in a black background? Once the two statements on the right are displayed in a black background, the top statement becomes difficult to read due to the low contrast between dark fonts and the black background. Contrarily, the statement at the bottom becomes very clear due to the enhancement of the contrast. In this example, we demonstrate various contrast levels of the same image. As you can see, the first row shows 3 grade level images. The center image is the original image with the middle contrast. As you can observe that the image on the left has lower contrast, and the image on the right has higher contrast. The corresponding histogram is shown below. From the three histograms, the distribution of the peaks and valleys in the histogram is still similar. The only difference is that in the image with the lower contrast, all bars are squeezed to a narrow area, while in the image with higher contrast, all bars are stretched to both sides. This indicates that an image with good contrast should fully utilize the entire intensity spectrum.